Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here. In this section, we're going to list and describe the functions of common network protocols, explain how network administration principles can be applied, and define the new types of network applications and how they can be secured. At the heart of every network lies protocols. Protocols are simply rules of conduct and communication. The governing protocol of the Internet is the TCP/IP protocol suite, Transmission Control Protocol Internet Protocol Suite, most common protocol suite used on the Internet today. The most common network protocols that you will need to understand and be familiar with are IP. This is the protocol that functions primarily at the OSI layer 3. TCP, which operates at layer 4, establishes connections and reliability of data transport between devices. Together, they make up the TCP/IP suite. It uses 4-layer architecture, the network interface, internet, transport, and application. There are two different models that you need to understand. The OSI model, which has layers 1 through 7, and the TCP/IP model. The OSI model is most commonly used for troubleshooting. The TCP/IP model, it correlates somewhat, and I'll break it down for you a little later, into the layers of the OSI model. The next protocol to understand is ICMP, or Internet Control Message Protocol. You may know it as ping. It's one of the core protocols of TCP/IP. It's used by devices to communicate updates or error information to other devices, primarily used to query and relay those messages. The ICMP message field is broken up into types, codes, and then a checksum, an 8-bit type, an 8-bit code, and then a 16-bit checksum. The checksum is there to verify the message integrity, and that it has not been disturbed in transmission. The different codes that you can receive using ICMP are 0, network unreachable, through 12, host unreachable for type of service. It's less important for you to know individually each one of these types of codes. Just be familiar with the concept of the ICMP codes. Some of the more common attacks that use ICMP are network discovery, you might know them as ping sweeps, or the ping of death, which is simply a malformed ICMP packet that once received by the targeted computer will bring the computer interface down, basically creating a denial of service condition. Next is the Simple Network Management Protocol, or SNMP. First introduced in 1988, supported by most network equipment manufacturers. Each SNMP managed device has an agent or a service that listens for and executes SNMP commands. The agents themselves are password protected, and there are 3 different variations that you'll need to understand. SNMP versions 1 and 2, not necessarily used as much today, but they are still out there today because of the vulnerabilities associated with versions 1 and 2. You should see SNMP version 3, introduced in 1988. It uses usernames and passwords along with encryption to address the vulnerabilities. Next is DNS, or Domain Name Service. It's simply a database with a name for each site and the corresponding IP address, mainly because humans do not understand and remember strings of numbers very well. So it's a helper, if you will, so you don't have to enter www.microsoft.com. This is so you don't have to enter the IP address for www.microsoft.com. DNS will do that for you. DNS is a wide focus of attack these days. Attacks such as DNS poisoning and zone transfers. DNS poisoning substitutes fraudulent IP addresses for the actual IP address that your user might be trying to reach, whereas a zone transfer allows the attacker to access the network hardware and operating system information. The TCP/IP protocols used for transferring files are FTP and SCP, File Transfer Protocol, and Secure Transfer Protocol. The methods for using the FTP on a local host, for instance, is by a command prompt or an FTP client. Using FTP behind a firewall can present some unique challenges. You'll need to set, for instance, your FTP client into FTP active mode or FTP passive mode, depending on whether or not it's sending, receiving, or both. Some of the vulnerabilities most associated with FTP is it's a clear text protocol. That means it does not use encryption to send files back and forth. Those files using FTP are vulnerable to man-in-the-middle attacks. Rather than using FTP, the simple unencrypted plain text form, it's encouraged to use secure transmission options like SFTP. This allows you to send the same file using basically the same protocol through a more secure encrypted channel. SCP, or Secure Copy Protocol, is an enhanced version of Remote Copy Protocol. This, however, encrypts the files and commands. It's usually found mainly on Linux and Unix platforms. However, there are special programs that can be employed in a Windows-centric environment. Next, let's talk about IP version 4 and IP version 6. The current protocol standard of the internet is IP version 4, although it is actively being phased out. Originally introduced in 1981, the number of available IP addresses is limited to 4.3 billion. Well, that sounds like a lot until you recognize that we are currently out of available public IPv4 space. That's why IPv6 had to be created. It's the next generation of the IP protocol that attacks the weaknesses of IPv4. It's a more secure and better standard by far. However, it is a lot more complicated. Here's a look at the differences in the headers between an IPv4 and an IPv6 packet. IPv6 provides enhanced security features like cryptographic protocols. Its new authentication header prevents IP packets from being altered in transmission. It is inherent where IPsec is inherent in IPv6, whereas IPsec has to be invoked or engaged with IPv4. Security is baked into IPv6 where it's absent in the IPv4 protocol. Here's a simple compare and contrast between the fields of IPv4 and IPv6. To successfully navigate the Security Plus examination, you should be familiar with these different fields and the explanation of what each field does. Next, let's take a look at some network administration basic principles. Administering a secure network can be challenging at best. Often, that's why this is why it's often thought to employ a rule-based approach to management of the network infrastructure. However, it does rely on following a certain set of procedures and rules. Those procedural rules will then dictate the technical rules that you will have to put in place. Some of those technical rules are device security and port security, for instance. With device security, it requires you to establish a secure router configuration, implementing flood guards, and analyzing device logs. The secure router configuration all begins at the network layer, or the OSI layer 3. Routers can perform a security function. They're not just there to route your traffic. It can be configured to filter out specific types of network traffic. So when designing a secure network infrastructure, there are certain tasks that should be checked off as you go. For instance, create the design first, put it on paper or on a whiteboard, visualize what the network should look like, use a meaningful router name, securing all the ports, set a strong administrator password, and only make changes from the console via remotely. Some of the some of the attacks that we need to deal with at that network layer begin with SYN flooding. This takes advantage of procedures for initiating a session in the three-way handshake, the SYN, the SYNAC, identified as the SYN and the SYNAC. We'll get into a little more of that later. Flood guards. These protect against denial of service attacks, commonly found on modern firewalls, IDSs, and IPSs. Log analysis, looking at your system logs and security application logs, setting the proper settings within the infrastructure devices to offload those logs for eventual review. Some types of security hardware logs that you'll want to take an active look at are the NIDs, the NIPs, the DNS, the proxy servers, and the firewalls. So NIDs, Network Intrusion Detection Systems, NIPs, Network Intrusion Protection Systems, DNS, proxy servers, and firewalls. We'll talk a little more about proxy servers and firewalls next. Some of the types of information that you are going to want to find in your log data include network messages from other services, dynamic updates, content of the question section for DNS query messages, the number of queries from a server that has been received, and the number of packets written by the server and back into the DNS zone, for instance. Here's a look at a basic firewall log. You see the local IP address, the destination IP address, and the permitted or denied service or port. And here's a look at a more detailed firewall log. You see all the same basic information, however, it gets more granular down to proxy and parent and proxy states of up, down, or permission or denies. Some of the things that you absolutely want to make sure to be examining in your firewall logs are the IP addresses rejected and dropped and unsuccessful logon attempts. These aren't the only ones, these are just the beginning. It's important to understand that networks, and especially in today's world, are going to change. They have to. They have to adapt to the customer base need. So whenever a network changes, it may need to be reconfigured or data rerouted to serve that ultimate need. This paramount should be of your concern, especially when it comes to network separation. Network separation provides separation between different parts of the network, entry and exit, or primary and D and Z. Options to accomplish this network separation is obviously to physically separate users by connecting them to different switches and routers, or possibly even air gap a switch. That will accomplish the separation that you need. However, sometimes it is not the most elegant of solutions, and sometimes it's not even practical. When configuring your network devices, especially your switches, you'll want to protect against broadcast storms. This is basically loopback protection. It uses the IEEE standard 802.1d spanning tree algorithm. It determines which switch has multiple ways to communicate with that host, and then it determines the best path to communicate to that host, and then blocks all other paths. Also, VLANs. VLAN management, when physical separation is not feasible, is the best way to segment up your network and segment them into logical groups of physical devices. This way, you can have your users spread across the world and still be logically connected together via VLANs. Some of the general principles for managing VLANs are that a VLAN should never communicate with another VLAN unless they're both connected to a router, and you should change any default VLAN name. It's also a good practice to disable VLAN 1, for instance, and assign the default VLAN to another number. You'll also want to configure VLANs so that public devices are not on a private VLAN. This is where you'll see the employ of internal and external DMZs, for instance. It's important to disable any unused ports on your routers and switches. That means to turn off those ports that are not required on the network themselves. All these ports should be secured before any switch or router is deployed, and your network administrator should issue the shutdown command to each unused port, physically going into the configuration of the device and issuing the shutdown command. Don't rely on it being defaultly shut down. This can and does provide a somewhat false sense of security. Next would be MAC limiting or MAC filtering. This simply limits the allowed devices to connect to any one given port. You can limit it to one and oftentimes maybe two. This is one of the best methods to physically protect the port on the switch itself from a malicious user. Some of the options that you have with MAC filtering is static MAC filtering. This is assigning a one-to-one, a known MAC address to a known port. Dynamic MAC filtering, when you don't know necessarily the MAC address that is permitted, you will open up for dynamic MAC filtering, and then the first device that plugs into that port will then get mapped to that port, and all others will be denied. Or sticky MAC. This is often found on Cisco devices. The MAC addresses are automatically learned and stored along with any other addresses that were learned prior to using sticky. This allows for a more dynamic and fluid environment. However, it is not the most secure of employ. Next would be 802.1x. This is the highest degree of port security. It implements port-based authentication. It blocks all traffic on the port-by-port basis until the client is authenticated to the environment. If the MAC is not stored in the MAC table of the environment, it will never be able to pass traffic. 802.1x is by and large the best standard to employ for network-based port authentication. There are 6 steps. To successfully navigate the Security Plus examination, you should be familiar with these 6 steps of the 802.1x process. Next, we'll talk about virtualization. Virtualization, simply put, means managing and presenting computer resources without regard to physical layout or location. The operating system virtualization permits you to simulate many different operating systems on a single host or physical host environment. The primary advantages that virtualization presents, especially to security practitioners, is it allows us to test the latest patches on and deploy them to a virtual machine before we have to send them out into production, so that we know how our environment is going to react to that particular patch. Virtual environments can also be used for training purposes and to do mock penetration testing so that you don't have to disturb your full production environment. Server virtualization can reduce costs and greatly reduce the energy use of, for instance, a large data center. It can help provide users uninterrupted server access via load balancing. However, it is not without its particular challenges as well. Virtualization, a virtualized environment, presents some security concerns, with a physical firewall not being able to inspect and filter the amount of traffic coming from running multiple virtual servers. Some hypervisors do not have the necessary security controls to keep out attackers, and existing security tools don't always adapt well to multiple virtual machines. And it is important to remember that virtual machines need protection from other virtual machines as well as other physical machines as well. So understanding all of the goods and bads, or pros and cons of virtualization, is important. However, you shouldn't shy away from virtualization simply because the advantages far outweigh the disadvantage. Some basic virtualization security tool features are restriction of changes and greater auditing capability. It allows for greater compliance in legal and regulatory arenas. It allows for on-the-fly customization for specialized user application, and of course, reporting, visual maps of which guests are running on which hosts, along with the network traffic patterns and the amount of disk storage attached can be generated on the fly with little or no production environment interruption. Next, we'll talk about IP telephony, or you may understand it as VoIP. It's a shift to all digital technologies in the infrastructure. It converges voice and data over a single IP network. Some of the advantages of VoIP are incoming calls can be selectively forwarded or blocked. So now an organization can downsize what used to be large office buildings where everyone in the same building to a large remote work base and a smaller office building, and yet still route all of those corporate telephone calls, for instance, to a remote worker's house. There are great cost savings that can be realized by employing VoIP, and also a reduced wired infrastructure requirement, reduced regulatory requirements, and absolutely increased user productivity. Many studies have found that remote workers or teleworkers are oftentimes 3 and 4 times more productive when working from home via an office setting. However, just like anything else, there are goods and there are bads. Some of the VoIP vulnerabilities that you should be familiar with are some of the operating systems, such as soft phones that operate on standard PCs that are vulnerable to operating system attacks. The VoIP protocols themselves have many common do not provide adequate call party authentication or end-to-end integrity protections. There is an inherent lack of encryption. You'll need to employ often another layer to enable encryption of those VoIP protocols. And of course, spam. Next, we'll discuss cloud computing. It's a pay-per-use computing model where customers pay for only the resources they need. Unlike hosted services, it does not require a long-term contract. There are 3 basic service models to deal with: cloud software as a service, cloud platform as a service, and cloud infrastructure as a service. Here's a look at some of the cloud computing characteristics. Most of them should look familiar to you. However, you should and must be familiar with each one of these to successfully navigate the Security Plus examination. Some of the basic security challenges that we face with cloud computing is the transmissions from the cloud must be protected. Customers' data must be isolated from other customers' data. This can be challenging in a large, for instance, software as a service or infrastructure as a service deployment. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.